Okay, let's continue looking at our test review here with question number 5. If x is between 0 and 2 pi, what are the solutions to 2 cosine x minus cosine x equals 0? Whoops, I think I didn't say squared. 2 cosine squared x minus cosine x equals 0. So on a problem like this one, where we've got a quadratic, we've got something squared, in order to solve it, we need to factor. Anytime you're trying to solve where you've got a quadratic, then you should try factoring. I've got two terms here. They both have cosine in them, and so we can factor out cosine x. So I'm going to factor out cosine x, and I would be left with 2 cosine x minus 1 equal to 0. Now remember, if you're having trouble doing that with the trig function, we can rewrite this as a squared, that would be 2a squared minus a equals 0, and then we could factor out an a, and we get 2a minus 1 equals 0. So if that's easier for you to work it that way, feel free to rewrite it and do that. Now at this point, once we have it factored, we need to set each factor equal to 0. So cosine x equals 0, or 2 cosine x minus 1 equals 0. And the second one, I'm going to go ahead and solve it for cosine x. I'm going to add 1 to both sides. And 2 cosine x is equal to 1. And then we'll divide by 2. Cosine x equals 1/2. So I've got cosine x equals 0 and cosine x equals 1/2. So now it's time to start thinking about our unit circle. Where is cosine x equal to 0? Now remember, cosine is the x coordinate on the unit circle, and so if it's going to be equal to 0, that means that we're on the y-axis somewhere. And so for cosine x equal to 0, our angles are pi over 2 and 3 pi over 2, because those are the two angles that are on the y-axis. Now for cosine x equal to 1/2, if I'm thinking about the first quadrant, cosine is equal to 1/2 at the pi over 3 angle. And so that's one of my answers for this factor, but I need to find the other answer. And so I think, in what other quadrant is cosine positive? Because my 1/2 is positive. And that happens in quadrant 4. So my other answer needs to come from quadrant 4. It's still going to be pi over 3. And in quadrant 4, that would be 5 pi over 3. And so there you have the 4 solutions to that equation. In this question number 6, what is the value of each of the following? And then we see some inverse trig functions here. So the thing to remember about the inverse trig functions I did it again. Here we go. For inverse sine, of x, the output or the range has to be between negative pi over 2 and pi over 2. And for inverse cosine, the output is going to be between 0 and pi. So what's going to happen on questions like this? Here on the first one, I see inverse sine and sine. Those are inverse operations, and they're going to undo each other. And normally when that happens, then our result is just what's left over here. But in this case, we need to consider the angle that's in here. Is that angle within the output range for inverse sine? Can this actually be an output of inverse sine? Well, negative pi over 3, it is between negative pi over 2 and pi over 2. It can be an output, and so that is our answer, negative pi over 3. All right, this cosine question, inverse cosine and cosine. Again, they're going to undo each other, which should be the output of pi over 3. But let's consider, is pi over 3 an acceptable output for inverse cosine? Well, pi over 3 is between 0 and pi. It is in the range. And so that's going to be the output. Let's look at these answers, these questions over here. Inverse sine and sine of 2 pi over 3. So this time I'm considering 2 pi over 3, and 2 pi over 3 is not between negative pi over 2 and pi over 2. 2 pi over 3 is not an acceptable result for inverse sine. And so we need to change it, and I'm going to write the result over here since I'm out of room over there at the side. It has to be some pi over 3 angle, but let's consider what it is. 2 pi over 3, that of course is in quadrant 2, and in that quadrant sine is positive. And so I want to go with a pi over 3 angle that's in the other quadrant where sine is positive, which would be quadrant 1. And so it's just going to be pi over 3. Pi over 3, that's my answer. This cosine, inverse cosine of cosine, and we're considering the 4 pi over 3. 4 pi over 3 is bigger than pi. That is not in our output for inverse cosine. So we need to figure out another angle. But I know it's going to be some angle that involves pi over 3. If we think about 4 pi over 3, that is in the third quadrant, quadrant 3. And in that quadrant, cosine is negative. So I want to think what other quadrant is cosine negative in, and that would be quadrant 2. And the angle, the pi over 3 angle that's in quadrant 2 is 2 pi over 3.